Kliklok-Woodman is nearly a 70-year company, and we manufacture food packaging equipment. We focus on 4 core industries, that being bakery, snack food, frozen and prepared foods, and cereal.
Select's machine is one of our in-load cartoners, the top-of-the-line in-load cartoner. It's what we consider our flagship machine on the cartoning side of the business. The 9-inch machine can go up to 325 cartons per minute. The essential function of the machine is to take the frozen food product and slide it into the carton that's been erected, and then glue the carton and discharge, obviously.
There's flaps on the end of the carton. The flap kicker will move the flap into the machine so the other flaps can close. They glue, it's glued and closed.
We had a similar mechanism that was pneumatic, which works fine around 175 per minute. But once you get above that, it just is difficult for a pneumatic actuator to keep up with those speeds.
Well, the logical approach was to replace it with a servo, but still, because of the speeds, there was a question, if the servo can do it reliably.
To help develop the servo-driven flap kicker, Kliklok-Woodman turned to Allen Bradley Motion Analyzer software from Rockwell Automation. Motion Analyzer is a digital modeling and simulation tool that helps size and select an optimal motion system solution.
Initially, what we did, we used actually Motion Analyzer and preliminary inertia value. We took a worst-case scenario to figure out what would be the most aggressive timing required to do the job. And then we did this preliminary sizing in Motion Analyzer just to see if a solution is even possible or achievable.
For many years, Kliklok has used Dassault Systèmes SolidWorks, a 3D CAD mechanical design software, to create cutting-edge mechanical designs. They were excited to learn that Rockwell Automation formed a strategic partnership with Dassault Systèmes to link SolidWorks with Motion Analyzer through API calls, which provides a live link between the 2 software packages.
When I got into it is, Florin would take SolidWorks, get the information out of that, create the profile in Motion, and then when we get to the actual motion profile of the servo, that's when I would get involved with Florin. Together we'd determine, what the speeds needed to be and what the motion profile would actually have to be.
The result was a new servo-based high-speed flap kicker system that uses Allen Bradley B310P MP series food-grade servo motors to meet the high-performance demands in a small space.
Where the software that Rockwell Automation assisted us with helped us to shorten the time frame of design. So instead of trial and error, we could do it basically over the computer. We could see what was going on. So the timeline and maybe the cost of even trying some and trialing that somewhere or making a rig to try it out, all of that time frame was shortened.
It probably saved us about a third the design time because we didn't have to rely on manual calculations or the physical trials.
The partnership with Rockwell is, I want to say, old and new. I'm sure we've used Rockwell components for many, many years in various places in our machines. But recently, we've become a part of your machine builder program. So everything's been hyphened with, the Rockwell organization.
On this machine, it's pretty much standardized on Rockwell. So the HMI is a PanaView Plus 1000. The servos are Kinetic 6000s. PLC is a ControlLogix L61. We have remote I/O. We use FlexPoint. The VFDs are PowerFlex 40Ps, so we use the safe-off version of that. And also on the Kinetic 6000 drives, we have the safe-off version of those. We're constantly in contact with Rockwell and our local distributor. It's just as far as using the new technology comes out, and also advice on how to use the equipment that we have. I mean, some of the stuff is not intuitive on how you're going to use it in this high-speed application. And so we have to go to Rockwell to say, hey, here's our application, and here's the hardware we're trying to use. Is that what we should be using, first of all? And if so, how should we use it? And not only in just the hardware, but also software. What's the best way to implement it in the software? Our main knowledge is from the packaging side of things. But when we were able to take their expertise from whatever they were doing, all the different projects, they can come in and say, well, okay, here's an entirely different way of looking at it that would work a lot better.